Hi everyone, Assalamualaikum. In this video, we are going to discuss integration techniques. Okay. There are 4 topics under integration techniques. Okay. The first one is integration of rational function using partial fractions. Okay. The second one is integration of trigonometric function, powers of sine, cosine, and secant tangent. Number 3, integration by trigonometric substitution. And number 4, integration by parts. Okay. First, let me look at integration of rational function using partial fractions. Before we go any further, we first look at the partial fractions. Okay. What are partial fractions? We can do this directly. Okay, 2 over x minus 2 minus 1 over x plus 2 equals to x plus 5 over x squared plus x minus 2, right? But how do we go in the opposite direction? Okay, from x plus 5 over x squared minus x squared plus x minus 2 to 2 over x minus 1 minus 1 over x plus 2. Okay. Alright. This is called partial fraction. Right. That is what we are going to discover. Okay. How to find the parts that make the single fraction is a partial fraction. Right. Why do we want them? Okay. Because the partial fractions are each simpler, right? This can help solve the more complicated fraction. For example, it is very useful in integral calculus, right? For the introduction of partial fraction, let's look at the pattern, alright? 1a, we have fraction with denominator x plus 1 and it is linear factor, right? So we can write denominator equals to a, which is constant. Okay. A here means only one constant. Okay. Because denominator has degree 1. Alright. Now we look at 1b. Okay. If we have denominator 2 minus x, okay, it is also linear factor. Okay. So we can write numerator equals to a, which is also constant. Alright. And then 1c, if we have denominator 2x plus 1, which is also linear factor, so we can write numerator equals to a, which is constant. Alright. If we have denominator with degree 1, okay, means linear factor, so the numerator should be 1 constant, okay, a. Alright. Okay, and then we continue with 2a. Okay, we have fraction with denominator x squared plus 1, okay, which is quadratic factor. And this is irreducible quadratic factor. Irreducible here means cannot factorize. Alright. So we can write the numerator equals to ax plus b, which is linear function. Alright. From numerator, we have two constants, a and b. Okay. Two constants here because denominator has degree 2. Alright. And then we continue with 2b. Okay. We have fraction with denominator 2x squared plus x plus 3, which is quadratic function. And this is also irreducible quadratic function because it cannot factorize. Okay. So we can write numerator equals to ax plus b, which is linear function. Right? And then 2c. we have denominator with 4 plus x squared, which is quadratic function. This is also irreducible quadratic function or quadratic factor. So we can write numerator equals to linear factor ax plus b. Okay, this is linear. Okay, in general, okay, if we have the denominator with degree 2, numerator should have 2 constants. Okay, if we have denominator with degree 1, numerator should have 1 constant. Alright. Alright, now we look at 3a. We have fraction with denominator x cubed plus 1, which is cubic function. So we can write numerator as quadratic function, which is ax squared plus bx plus c. We have 3 constants a, b, and c because denominator has degree 3. Right? And then 3b. If we have fraction with denominator 4x cubed, it is also cubic function. Okay, so we can write numerator equals to ax squared plus bx plus c, which is quadratic function. Alright. And then we continue with 3c. Okay, we have fraction with denominator 2x cubed minus x squared plus 3. Okay, this is also cubic function. Okay, so we can write numerator equals to ax squared plus bx plus c. Okay, so this is quadratic function. Alright. And then we look at for a. Okay, we have denominator with x to the power of 4 plus 2. This is quadratic function. Okay, so if we have denominator with degree 4, we should have numerator with cubic function, okay, which is ax cubed plus bx squared plus cx plus d. We have 4 constants here, a, b, c, and d, because denominator has degree 4. Right? And then we continue with for b. We have fraction with denominator 2x to the power of 4 plus x plus 3. This is also quadratic function. Okay? So numerator should be cubic function ax cubed plus bx squared plus cx plus d. Alright? And then for the last one, okay, we have the fraction with denominator 3x to the power of 4. This is also quadratic function. Okay, so we can write numerator equals to cubic function ax cubed plus bx squared plus cx plus d. Alright, in general, okay, if we have denominator with degree 4, so we should have 4 constants a, b, c, and d. If we have denominator with degree 3, we should have 3 constants a, b, and c. Alright? That's the concept to set up the partial fraction. Alright? Alright, now we continue with partial fraction decomposition. Okay? Type 1, denominator with distinct linear factor. Okay, so we look at this fraction. We have x over x plus 1 times x minus 2. Okay, this is distinct linear factor. Okay, and when we expand the denominator, we has degree 2. Okay, and numerator has degree 1. Okay, so this is called proper fraction because the degree of top is less than the degree of the bottom. Right? So, if we have proper fraction, we can write into the sum of partial fraction. And to write into the sum of partial fraction, first we look at the denominator is distinct linear factor. Okay, so we can equate to, okay, from denominator we have two linear factors here. So we can equate to two fraction. Alright, and in between must plus sign here. Okay, and the first denominator should be the first factor. Okay, and the second denominator should be the second factor. Okay, so from here, okay, we have denominator with x plus 1, which is linear factor. So we can write numerator equals to constant, okay, a. And then from the second fraction, we have denominator x minus 2. It is also linear factor. So we can write another constant b. Okay. This is also constant. Okay. And then from here, we have two constants a and b. Okay, because from the original fraction, we have denominator with degree 2 if we expand here, right? Alright, still under denominator with distinct linear factor type 1. Okay, now we continue with 1b. Okay, we have fraction x minus 3 over x plus 1, x minus 1, x plus 2. Alright, from denominator we have 3 multiplication of distinct linear factor. Alright, and if we expand, okay, the denominator has degree 3, okay, and numerator has degree 1. Okay, so this is proper fraction. Okay, so the degree, so we can express into the sum of partial fraction. Okay, this is called proper fraction because the degree of the top is less than the degree of the bottom. Alright. Okay, so from this fraction with denominator distinct linear factors, okay, we can equate to 3 sum of partial fraction. Alright. The first denominator should be the first factor, which is x plus 1. The second denominator is the second factor, which is x minus 1. And the third denominator is the third factor, which is x plus 2. Okay, and then from the first fraction, we have denominator x plus 1, which is linear. Okay, so we can write numerator equals to constant a. Okay, and for the second partial fraction, okay, we have denominator x minus 1, which is also linear. So we can write constant b. Okay, for numerator. And then for the last fraction, we have denominator x plus 2, which is also linear. So we can write numerator equals to constant c. Alright. Alright. From here, okay, we have constant a, b, c. Okay, we have 3 constants here because from denominator, from the original fraction, if we expand denominator, we will get degree 3. Okay, so that's why we have 3 constants a, b, and c. Okay, if we have denominator with 3 distinct linear factor, we will write into the sum of 3 sum of partial fraction. Alright. Alright, now we continue with type 2 denominator with irreducible quadratic factor. Irreducible quadratic factor means the quadratic function cannot factorize. Alright. Okay, now we look at 2a. Okay, we have fraction 3 over 2 minus x times 1 plus x squared. Okay, from factor 1 plus x squared here, this is irreducible quadratic factor. Okay, and when we expand denominator, we have degree 3. Okay, and numerator has degree 0. Okay, so this is proper fraction because the degree of the top is less than the degree of the bottom. So if we have proper fraction, so we can write into the sum of partial fraction without doing long division. Alright? So from irreducible quadratic factor, okay, now we have two factors here from denominator. So we can write sum of two partial fraction. Okay, the first denominator should be the first factor, which is 2 minus x, and the second denominator should be the second factor, and in between must plus, right? And then from the first fraction, we have denominator 2 minus x, which is linear factor. So we can write numerator equals to constant a. Okay, and for the second fraction, we have denominator 1 plus x squared, which is irreducible quadratic factor. So we can write numerator equals to linear function bx plus c. Alright, and from here, we have constant a, b, and c. Okay, there are three constants here. Okay, because when we expand denominator, we have degree 3. Alright, so that's why we will have three constant a, b, and c if denominator for the original fraction equals to degree 3. Alright. Alright, still under type 2 denominator with irreducible quadratic factor. So now we look at 2b. Okay. We have fraction 1 plus x over x squared times 1 plus x squared. Okay. From 1 plus x squared here, okay, this is actually irreducible quadratic factor. Okay. And when we expand the denominator, we will have degree 4. Okay. And numerator has degree 1. So this is proper fraction. So we can write this fraction into the form of sum of partial fraction without doing long division. And this is called proper fraction because the degree of the top less than the degree of the bottom. Alright? So from here, okay, we express into the sum of partial fraction. Okay, the first denominator should be x squared and then plus. The second denominator should be 1 plus x squared. Okay, and then from x squared here, okay, this is quadratic factor. Okay, this is also repeated factor, but we will discuss later. Okay, now we consider x squared equals to quadratic factor. So we can write linear factor ax plus b. Okay, and then for denominator 1 plus x squared, this is irreducible quadratic factor. Okay, and we can write linear factor cx plus d. Okay, we can double check. Okay, we have constant a, b, c, and d. There are 4 constants here. Because when we expand denominator from the original fraction, we will get degree 4. Okay, that's why we have 4 constants here, a, b, c, and d. Right? Alright, now we continue with type 3a. Denominator with repeated linear factor. Okay, we look at example 3a. Okay, if we have fraction x over x plus 1 bracket squared, okay, this is called repeated linear factor. Okay, from squared here, okay, this is degree 2 when we expand. Okay, and from numerator, okay, we get degree 1. Okay, so this is proper fraction because the degree of the top is less than the degree of the bottom. So we can express this fraction into the sum of partial fraction without doing long division. Alright? Alright, from the original fraction, okay, we have denominator with squared here. Okay, so this is called repeated linear factor. Okay, so we can write into the sum of partial fraction. First, denominator should be x plus 1. Okay, actually this is bracket the power of 1. Okay, and then plus the second denominator should be bracket squared. The same factor, the same linear factor, but we must write bracket squared. Okay, so now we have squared here, repeated linear factor. So first, we must write bracket the power of 1, but no need to write for the power of 1. And then bracket squared. Okay, we stop until squared here because the given repeated linear factor here is squared or bracket to the power of 2. So we stop until to the power of 2 here. Alright. And then now we want to write the numerator. Okay. So we can consider the denominator. So from the first fraction here, denominator is linear. So numerator should be constant A. Okay. And then for the second fraction, okay, we just consider the factor inside bracket. Okay, the factor inside bracket is linear factor. Okay, so when we have denominator with linear factor, we will have numerator with constant. Okay, so we write constant B. Okay, then we can double check. We have constant A and B. Okay, there are two constants here. Because when we expand the original denominator, okay, we will have degree 2. That's why we have two constants here. Right? Right, and then we look at example 3b. Okay, under type 3a denominator with repeated linear factor. Okay, we have fraction x plus 1 over 1 minus 2x bracket cube. Okay, so this is also repeated linear factor. Okay, so from here, when we expand, we have degree 3 in denominator. And in numerator, we have degree 1. So this is also proper fraction because the degree of the top is less than the degree of the bottom. Okay, so when we have proper fraction, we can express into the sum of partial fraction without doing long division. Alright. So from here, okay, we have bracket cube here or bracket to the power of 3 here. Okay. So this is a repeated linear factor. So we can write into the sum of partial fraction. First, denominator we can write 1 over 2, 1 minus 2x. Okay. Actually, we have bracket to the power of 1. Okay, but no need to write. Okay. Okay, and then plus, the second denominator should be 1 plus 2x bracket squared. Okay. And the last factor should be, the last denominator should be 1 minus 2x bracket cube. Okay. So the concept for repeated linear factor, if we have linear factor with to the power of 3, okay, we need to repeat from the power of 1, okay, the power of 2, and we stop until the power of 3 because the given denominator here is to the power of 3. Alright, so we start with to the power of 1, to the power of 2, and to the power of 3. Alright, and then to the power of 1 here, actually no need to write. Okay, and then from the first denominator, okay, this is linear factor. Okay, so we can write numerator equals to constant A. Okay, and for the second denominator, okay, we just consider the factor in bracket. So the factor in bracket is linear factor. Okay, so we can write numerator equals to constant B. Okay, and for the third fraction, we also consider the factor in bracket, which is also linear factor. So when we have denominator with linear factor, we must write numerator with constant. Okay, we write constant C. Alright, so we can double check. Okay, we have constant A, B, and C here. There are three constants because from the original denominator, if we expand, we will get degree 3. That's why we have three constants here, A, B, and C. Right? Alright, now we continue with example 3C. Okay, we have fraction x squared plus 1 over 1 minus 2x to the power of 4. Okay, this is repeated linear factor. Okay, and when we expand denominator, okay, we have degree 4 here. And numerator has degree 2. So this is proper fraction because the degree of the top is less than the degree of the bottom. Okay, so we can write into the sum of partial fraction without doing long division. Alright. Okay, from bracket to the power of 4 here, yeah, this is repeated linear factor because in bracket is linear. Okay, then we can write into 4 partial fraction. Okay, so the first denominator should be 1 minus 2x bracket to the power of 1. Okay, plus, and then the second denominator should be 1 minus 2x bracket to the power of 2. Okay, and then plus the third denominator should be 1 minus 2x to the power of 3, and the last one should be 1 minus 2x bracket to the power of 4 in denominator, right? Alright, from to the power of 4 here, okay, we repeat from bracket to the power of 1, okay, and then bracket to the power of 2, bracket to the power of 3, and bracket to the power of 4. Alright? This is the concept we use in repeated linear factor. Okay, we repeat based on the given power here. Alright? Okay, so now we want to write the numerator for each fraction. Okay, so we consider the denominator. Okay, from the first fraction, we have denominator 1 minus 2x, which is linear. So we can write numerator equals to constant A. Okay, and then for second denominator, okay, we have in bracket, we just consider in bracket only. Okay, for repeated factor, okay, we have 1 minus 2x, which is linear. So we can write numerator equals to constant B. And then for the third fraction, in bracket, we have linear factor. So we can write numerator equals to constant C. And for the last one, we have denominator in bracket, okay, equals to 1 minus 2x, which is linear. So we can write numerator equals to constant D. Alright. Then we can double check. We have constant A, B, C, and D. Okay, because when we expand the denominator from the original fraction, we get degree 4. That's why we have 4 constants here. A, B, C, and D. Alright? Alright, now we continue with type 3B. Denominator with repeated irreducible quadratic factor. In the previous slide, we discussed denominator with repeated linear factor. Okay, but now we discuss denominator with repeated irreducible quadratic factor. Okay, we look at 3D. Okay, we have fraction x over 1 plus x squared bracket cube. Okay, so this is repeated irreducible quadratic factor because in bracket is irreducible quadratic factor. And when we expand the denominator, we will get degree 6. Okay, and from numerator, okay, we have degree 1. So this is proper fraction because the degree of the top is less than the degree of the bottom. Okay, so when we have proper fraction, we can expressed into the sum of partial fraction without doing long division. Alright. So from bracket to the power of 3 here, okay, which is repeated irreducible quadratic factor, so we can write into 3 sum of partial fraction. Okay, the first denominator should be 1 plus x squared, okay, bracket to the power of 1, and then plus the second denominator should be bracket 1 plus x squared and then squared. Okay, and then the last one we have denominator with 1 plus x squared bracket to the power of 3. Okay, we double check. Okay, we have bracket to the power of 3 here. So under repeated factor, we need to repeat from to the power of 1, to the power of 2, and to the power of 3. Right? Because the given power here is 3 here. Alright? Alright, and then now we want to write the numerator for each fraction. Right? So actually 1 plus x squared bracket to the power of 1 here, no need to write. Okay? Okay, and then 1 plus x squared here from denominator here. Okay? This is irreducible quadratic factor. So we can write numerator equals to linear factor ax plus b. Okay? And then for the second factor, okay, for repeated factor, we just consider the factor in bracket only. Okay, so the factor in bracket is irreducible quadratic factor. So numerator should be linear, which is cx plus d. And then for the third denominator, okay, we have in bracket 1 plus x squared, which is irreducible quadratic factor. So we can write numerator equals to linear factor ex plus f. Alright, then we can double check. Okay, we have degree 6 here. Okay, if we expand denominator here, okay, and we will have constant a, b, c, d, e, and f. Okay, we have 6 constant here. Okay, because the degree of the original denominator when we expand, okay, equals to 6. That's why we will have 6 constant a, b, c, d, e, and f. Alright, that's the concept for partial fraction decomposition. Right? Coming up next, example for partial fraction. Thank you for watching. Stay tuned. Bye. Assalamualaikum.